talk a little bit about what we think of as extended intelligence. And the first part of the program, if we could get the first video up, here we go. The first part of the program, we quickly showed these metrics in the radar plot. We have many different ways of looking at it. We mostly focused on the environmental, not so much on the economic or the social. These two guys have taken a lead in putting much of this together. So I'd maybe start with Ronan. What is interesting about our economic metrics here?
Well, it depends a little bit the kind of context that we're working with, but a lot of places that we're working with, they're trying to create a district that's really innovative, trying to maybe replicate something like the success of somewhere like Kendall Square. And so, we know a little bit about the kinds of ingredients that are necessary for innovation. So you need things like companies investing in R&D, you need the presence of a world-class university, you need diverse range of skills and abilities, and then facilitating interaction between those diverse sets of people. And so we develop different kinds of metrics to kind of indicate those various aspects. But then, other areas, innovation is kind of a nice to have, but it's not necessarily top of mind. Some places are more looking at kind of more basic measures of economic success. They just want to have kind of attainable jobs that can supply a living wage. So we kind of have to have more other measures that are more related to those kind of basic aspects of economic success. So it depends a little bit on the context.
Yeah. And so Luis here, we have a different radar plot. It's proximity, density, diversity. These are with respect more to the physical dimensions of an area. What do you think is most important about those metrics?
Well, first of all, I think it's very important to show these two radars because we are connected the traditional economic, environmental, and social indicators with the physical environment through the density, proximity, and diversity. If you ask me about the social indicators, probably the one that I love the most is well-being. Why? Because it's messy, it's super difficult to calculate, and there is a lot of quantitative and qualitative information, and it's very related to the local situation. So, yeah, I think that's one of the indicators that are much interesting for me. I don't know if you want me to...
Well, you also see innovation potential.
Oh, yeah.
So how do we calculate innovation potential? It seems very murky.
Oh, yeah, that's another messy one. I see, Kent, that you like getting into the difficult ones. So right now, there are different ways. We have Christian, that he was a PhD student working on innovation in the country level, and then we reduce it into we kind of have a version for the district level where we were looking for diversity of people sharing ideas, but also places where they were sharing ideas. For instance, Andorra, that is, we have people from Andorra here, probably they have the same diversity than Kendall Square, but the interaction between the diversity in Andorra is a little bit different because they have tourists. In Kendall Square, you have the same diversity, but you have the institutions and the places to have that interaction.
Right, and it's also the amount of time that people have opportunity to interact. A science park might be 9 to 5, but a science neighborhood could be 24/7.
Yeah, exactly.
Yeah. Let's look at this. So this is our Cityscope model of Kharkiv. Now, we don't really think of this as a master plan. It really is kind of an extended intelligence platform. But what does extended intelligence mean to you?
I mean, for me, it's kind of just letting the humans do what they're good at and letting the machine kind of augment that intelligence by doing the things that they're good at. I mean, probably the next slide kind of highlights this a little bit more as well, but the humans can kind of make the major design decisions, but then there are certain aspects of the design that are a little more intricate, where there's a lot of different variables involved, and human intuition is kind of we don't have great intuitions for the difference between whether this is a 5-story building or a 6-story building and what's optimal. So we kind of use the combination of the human intelligence augmented by the machine intelligence to kind of fine-tune the decisions of the designers and the outcomes of the traditional design process.
And Luis, in this video, I think it'll play in a second, there you can see the radar plot, and it's updating in real time as people are making changes. So what is that responding to that the humans are doing?
Well, in this case, something that is very important is that we don't have like fixed indicators. Each project has their own challenge, and we have to build different indicators depending on the context. Here, this is a placeholder for Kharkiv. So that radar actually is not like a fully functional kind of radar. That's the whole purpose of this collaboration, not trying to get the data, try to get the unlikely partners around the table, the industry, the academia, the government, and the citizens making decisions. So this is just a first step, a strawman proposal, and in this case, this radar, again, the other ones, you could see that they had much information because we had data.
All right, last video. Okay, so this is a digital model, it's not a physical model. And Ronan, you built this model. Explain what you are manipulating here.
Yeah, so this is where the outcome of either like a traditional planning process or even a process facilitated by something like a cityscope would produce kind of basic design parameters, like where does residential go, where does different industries go. But then when you want to kind of fine tune these kind of intricate details, you can use some kind of a generative or optimization model, which kind of takes all of those decisions from the people as parameters to work within. So the heights need to be between this, and you need to have this number of people employed there, and so on. And here there's restrictions on land uses in different areas, but then the model can kind of optimize within those parameters for some kind of well-defined objective. And in this case, it's just objective. It's maximizing for proximity between homes, workplaces, and amenities, but this could be optimizing for anything like CO2 emissions.
So in other words, as people are making changes to those sliders in this case, you are programming it to keep the live-work relationship in harmony as well as the amenities.
Yeah, so
in that sense, it's generative because anything they do achieves that kind of harmony.
Right. So it's always trying to keep those things in balance, and then you're just kind of tuning the parameters that it has to operate within.
Right. So in this case, this is a little more detailed model, presumably that it would come later in the process. And now you see the hint of, some texture and materials. This is all AI generated. And so, Luis, what do you think is the potential of this?
I don't know, Kent. This is your thing.
Well, okay. So, these AI tools are amazing. They surprise you, they delight you, but they're not connected to a model like this yet. I mean, they're really disconnected. They're text-based. So what's beautiful about it potentially is that people in Kharkiv, for example, could express verbally what their vision of a streetscape could be, in terms of the elements that they interact with. But then what is generated ultimately should be connected to these three-dimensional models, and you bring together AI and generative tools and all the metrics. We're a long ways from that, but I think these tools will transform architecture and urban planning. I think we're just beginning to see the potential. I think it could go either way. It could make it much easier to do terrible work, or it could empower creative people to go much farther and to produce more responsive work. So we'll see. All right, that was fast. We're out of time. All right, thank you.